Yeah. For number two, why is it shaded like in that part?
Yeah, sorry, I think I meant to indicate that I'm subtracting that portion out.
Okay.
Maybe this is better. Right. Ultimately, that's my goal, to get that red shaded region. So I'm gonna find the area of this semicircle, subtract these out, and then what's left is inside the circle, but outside the circle.
Does it also work to find the area of the whole circle and subtract the cardioid part?
Well, this portion we don't want, right?
Okay.
If we subtract the cardioid, then we're subtracting this, and we don't get to that.
Um,
So I'm just thinking, what if we just find the area of this whole thing, subtract that out, and then what's left is this red shaded region.
What I did was. There you go. 5 to 3 to 5. And yes, this so a little bit like this. But only like this. See this. Focus. How about this circle here, right? So, back up, it's not, it's good. Good, do this whole thing, good, you're gonna do this region as well. Why would that? Oh, it could be close, use the focus stuff. Well, so my strategy here is. Sorry.
You're on page 60, right? So my strategy is, this is easy, right? That's just a semicircle. I don't worry about that. I can find that. Eventually. The hard part is trying to figure out this, this shaded region. But if I can figure this out, I can double it, get that. I just have to worry about how to get that. So, now let's do this first. There's the intersection, right? I'm going to find this piece first. That's from pi over 3 to pi over 2. This is hitting the r equals 2. Oh. And then I don't want this whole thing, because this white part, I don't want that part, so I got to subtract it out. That part is from 0 to pi over 3. I'm sorry. Still, my bad, still pi over 3. We're just building that whole thing, but it's hitting. We want to subtract out the portion that's hitting this graph, right? So this portion, we want to basically subtract that. That's hitting the R or cosine. Yeah, you have this, double it, you get these two regions, and then add a semicircle, and that's your answer.
Is there other ways to do that? No. That's the only way.
I think there are other ways to do this, but they all involving subtracting something from this region. I mean, you can try other ways. If you're able to get to the same numeric answer, let me know. We can discuss that.
Is that like that method's kind of like hard to like strike my mind. It's like
Right. Well, I think maybe something that helps is that knowing that I gotta involve this somehow, right? I can find that area, right? But I know that's too much. I gotta subtract something out. So I gotta think about, okay, how do I get rid of the part that is not part of this diagram? And this is more than that.
yeah.
So the hard part is figuring out how to get in that direction. So something that does help is, making the graph as big as possible so you can kind of see the distinction maybe. This entire sector.
And then like the angles like always keep changing. So like sometimes pi over 2 is pi.
Yeah, that's true. Yeah. Not every graph is starting at the same place.
Right.
So that's something to consider as well.
Yes, good. Okay, and then your worksheet 1 through 4, and that's what you're done with.
Sure.
Mhm.
You hear me out. It's okay for me to integrate to find the circle. Yes, that's what I did, and I got something else.
So we're trying to find this area, right?
Yeah, it's that minus that. Yeah, I like shaded the opposite area.
Yeah, so my strategy is. My strategy is, I found this area first. Then I subtracted this portion. And then what's left over is this piece that I want, right? This outer region.
Okay. So like the cardioid, the angles are probably here, right?
Here.
Makes sense.
Right, but it's also good to kind of feel like that we know where the graph is building from, right? So the cardioid at 0, it's 1 minus cosine of 0, which is 1 minus. It starts at 0, that's good, right? And then at pi over 2, 1 minus cosine of 2 is 1 minus 0, which is 1. So we know that the cardio starts here and it moves this direction. So if I can figure out this region, then I can subtract that out.
So we're trying to find this area. What you do is and then up like this function. Then if I were free to find this function, but you wrote instead of 5 region. So I just wanted to make sure. Oh. That gives you the answer to. Check it. On the tape.
When you go from here to here.
That's just a double angle identity, but you don't have to do this. You can just plug in the calculator.
Okay, okay.
Yeah, yeah. Neil, thanks for that catch. Let me change that. Guys, on number 8, I made a mistake on worksheet 2. Let me just walk through it with you guys. So okay, so number 8 says find the area of the region common to the two regions. You got r equals 6 cosine theta. That's the circle that's sitting to the right of the y-axis. And then you have r equals 2 plus 2 cosine theta. That's the cardioid here. So I'm going to have that the curve r equals 6 cosine theta. Okay, so that's in green, right? The R6. And then the 2 plus 2 cosine theta, I'm gonna have that in red. So first thing is intersection, right? Let's find the intersection. So we care about this point here because ultimately we're trying to figure out the shaded region here. So 6 cosine theta equals 2 plus 2 cosine theta. We set them equal to each other. We solve for cosine theta. We solve for theta. We get pi over 3 and 5 pi over 3. I don't care about this here. I just care about this region, and I'll double it at the end. First, we know we got to start at the origin. We have to build out so the r 2 plus 2 cosine theta starts here, right? Cosine when theta is 0, we're here, and then pi over 3 is here. So we know that this region will cover what we care about for the 2 plus 2 cosine theta. So that's here from 0 to pi over 3, 2 plus 2 cosine theta squared, 1/2, and then ultimately I'm going to double it to take care of this region down here. All right, Now, the next part is from pi over 3 for the 6 cosine theta, which is the circle, right? To pi over 2, because our 6 cosine theta will complete its full cycle between 0 and pi. So here it's going to be at pi over 2, it'll be at 0. We can double check that. And if I plug pi over 2 in for theta, I get 6 cosine of pi over 2, which is 6 times 0, which is 0. So I made a mistake here. I put pi, but I should have put pi over 2. And then that will add that green region that's part of the circle. 1/2 integral r squared, but then I'm doubling it to take care of this bottom region here as well. So 14 plus 1 is 15.708. So do number 8 first, since the key is wrong, and I want you guys to have this down. Just cross off the answer for the key.
And Thank you.